All right, this is going to be really similar to our last lesson on perimeter. And this one, we're going to talk about area. In fact, honestly, this one's probably going to be even shorter. We're going to focus on the formulas and reminding you what the formulas for area of the same 5 shapes is. And because this is the most likely to be review of almost anything we have in this chapter 0 stuff. And so we're going to mostly focus on the formulas, and then we'll see about doing example videos as needed. So let's jump right in. We're going to start with rectangle, where if you for some reason have watched this out of order or something like that, then and you don't know what any of these little marks on the shapes mean, then make sure you go back and watch the perimeter video first, because I went over all of that in that video, and so I'm not going to take the time to do that here. So we're just going to take a look at area. So perimeter is the length around, so it's adding up all the sides. Area is the amount of space on the inside. So we're moving from a one-dimensional unit, a one-dimensional idea, to a two-dimensional unit, because we're talking about all of the space inside that shape, right? And so I said that perimeter, the units are distance. Well, this time we're going to be multiplying, and we're going to illustrate what the units are by looking at the formula. So to find the area of a rectangle, we take and we multiply the length times the width. Now, if you haven't seen this before, I'm going to leave this as just LW, as if for some reason you haven't seen this before, whenever we have 2 letters right next to each other, that means multiplication, which is the same as if we had a number. And we saw this kind of in the perimeter videos where it's, and I forgot to mention it, but if we have like 2 times W or 2W, that's the same as 2 times W. There's a lot of different ways, and we'll get some of this when we talk about multiplication of integers and some of those topics. And we I guess we kind of did, but those are, that just means multiplication. So in case you didn't pick that up in some of those other videos and you didn't catch that, that's what this means. We don't need a time symbol or a dot or parentheses or anything. So area is length times width. That's it. And so because of that, we have a distance times a distance. So we have like, let's say centimeters times centimeters, right? So if you have something times itself, that is squaring the something. And so the units for, and we won't write them all, obviously, because there's a ton of them. But the units are squared units for area. So we're talking about like centimeters squared, like I just said, or inches squared, or yards squared, or miles squared, or you know, any of those things. So we get squared units because, and it's easiest to illustrate with the rectangle because we have a distance times a distance, and we're talking about 2 dimensions. All of the reasons, for all of those reasons, we have squared units, which is important because word problems have units. Picture problems mostly have units. All right, so that's I said before that was important to get in our head, and it still is. So let's look at the formula for the parallelogram. Now, you may remember from when I talked about perimeter that the parallelogram and the rectangle formulas are really similar. Now, in this case, they are the same formula. However, I need to actually, when I was adjusting this file, I forgot to kind of add this. So we get to do this kind of in real time, because it's not like I just had, I'm going to put back what I just erased. If we have the side, this length A and this length B, it's the area is not those 2 multiplied together. It is just 2 things multiplied together, right? And it is, but we have to have some different things going on. What we have is we have this length, which this is I'm going to put that down here. I think that's going to look better. I don't know, some sort of like obsessive moment or something. I don't know. So this is the height of this parallelogram. And this down here, we usually label as the B for the base. Okay, so now the area is the base times the height. Now, why is that? Well, I'm gonna take a minute and go and jump to the next shape to illustrate. Actually, the next, I think it's the next shape. But I'm gonna jump to the triangle shape. So to find the area of a triangle, you may remember, it is, to find that one, it is 1/2 of its, now I'm gonna make some adjustments here too on what we're labeling here. Who cares the color, right? Let's get this in here. This is the height of the triangle, and this is the base of the triangle, right? So it is 1/2 of the base of the triangle times the height of the triangle, right? There's actually other ways to find the area of a triangle, which you probably won't learn until you get to pre-calculus. But there are other ways to find it if you don't have both of these values. But for a long time, this is going to be the formula we use. So this is the formula to find the area of a triangle, which you probably already know. Now, let's go back to our parallelogram now that we've got that formula, because we're going to use this idea to kind of illustrate why the area of a parallelogram is what it is. Because like this is a formula that often confuses students, and they don't, and it's hard to see why. It's because this is like basically the same as the rectangle formula. Why can, if we take and we smoosh it over, why can we still essentially use the same formula? Why does that work? Well, here's why it works. And this is going to help some of you, and some of you don't really care, and you're just going to use the formula and move on. And both are valid. You're just going to believe that it's true and move on with it. But if you're one of the students, as many are, who are looking at this and thinking why, and it's going to help you, this is for you. Right? So to find the area of this internal rectangle that I kind of drew, you see I drew another height on here, right? You would do B times H, right? B times H. But you wouldn't even do B times H. You would do B minus this little section, right? You would do this little, you'd find the area of this rectangle, right? And then you would... All right, so I paused this video because I realized the way I was explaining is probably going to confuse people. And so I took a little second to add a tool to help us understand what's happening. So this triangle over here is the same as this triangle over here. And we could use theorems and stuff in geometry to prove that, but it's the same, and it makes sense that it's the same just looking at it, and which is not enough for geometry, but it's enough for us. It makes sense that this triangle is congruent to that triangle. They're the same triangle, right? And so what I did here was I did it in purple so it's easier to see. I added this triangle in. So if I take this triangle and I stick him over here. And so what I have done is I have cut off. I think I can do this and then undo it as I explain. So I cut this triangle off. Oops, I need to be in this layer. I cut this triangle off and I put him over there. Right? Now this B is still the same. It's still this entire length. And this H is the same. So if we take and we chop that triangle and put it over here, now we have a rectangle. Right? We have a rectangle that is the base times the height, and it's the same thing. And so that is kind of why this works, right? That's kind of why we can do that. It's because that if we kind of do a little surgery, we're essentially turning it into this rectangle. So that's why this formula works. And so I'm going to kind of leave this as a symbol of why this formula works. But for the others of you that just want the formula is the base times the height, not this sort of slant height over here. And that's important when we're talking about a parallelogram. You have to have the height, which is this one. Which is perpendicular to the base, right? This guy right there. Another word for that is altitude or whatever. So it's the base times the height on a parallelogram, which is very similar to the rectangle formula, and it's because of what I just showed you. Now, moving on to the square. Now, the square is kind of an easy one, right? So square is just a rectangle. Not every rectangle is a square, but every square is a rectangle. Now, how do we find the area of a rectangle? We do length times width. Well, in this case, the cool thing about a square is the fact that they're both the same, right? Oops. They are both the same. So we've got side and side times side. Side times side is side squared. So the formula for area of a square is just one of the sides squared. Easy peasy. We've already got the triangle one, but I'll put it back up in kind of the normal flow. The formula for area of a triangle is the 1/2 the base times the height. Another way to write this formula, I will go ahead and add, is you can, because of the way multiplying fractions work, you can write this as b times h divided by 2. It's the same. It's mathematically the same way. These are identical. It's just another way to write that formula. So the fifth and final formula. I left my little diameter and radius notes on there from last time, and all of that. So that's all there. I said this already in this video, but if you haven't watched the perimeter one first, you probably want to watch it because it's got even fuller explanations on some of the things. So to find the area, now there's not a fancy word for the area of a circle. Like for perimeter, we had circumference, so we had a fancy word. For area of a circle, it's just area of a circle. No big deal, right? So we're going to use pi again. And remember, like I told you in the last video, when we're using pi in a formula, you want to use that pi button on your calculator from here on out, because as you're going to get a more precise answer, and you're more likely to exactly get the answer that's in the book or the answer in the key or any of those things. But the area of a circle is found using the formula area equals pi r squared. Now this like I said in the perimeter video, this formula, it doesn't have a diameter version. Now we could make one, right? But it would be much more complicated, right? But for the area of a circle, when we're using pi, we use radius in here because the formula is simpler. And so that's why I like 2 pi r. Then we've got radius in both formulas, and we're always using the same variable, but you could use pi d. But that's last video. And speaking of last video and end of video, that's really all we're going to do in this particular video. You just use these formulas the same way you use the perimeter formulas and any other formulas. You just plug the numbers in and get your answer. Hope this has been helpful. If you're one of my students, I'll see you in class. Do your homework, all the things. If you're not one of my students, thanks for being here. Let us know how else we can help you in your math and science journeys, or even just general homeschooling stuff. See you later. Bye-bye.